Okay, so here we have the Rega A2D Phono Preamp that I couldn't help myself and needed to make a few changes to. This is what it looks like inside when you pull it out of the box. Now you can see I've made a few mods here. There was a couple of things that annoyed me about it. One was that I thought it was a little bit lacking in top end, so I discovered there's two resistors here, R13 and R22 and R23, and if you adjust those two, you add top end. It seems to be like a bias adjustment for this circuit here, which is where all the heavy duty lifting is being done in the preamp section. So I've run that one to this new pot here, and I've run the right hand channel to this new pot here. This is a dual gang pot. It's a B10K pot, and you only need about 5K worth of adjustment. So I've put a 4K7 and a 4K7 across it just to take down the amount of bite that pot has, and now you sort of get a little bit duller turning it one way and a little bit brighter than it originally was when you turn it the other, so you can balance nicely to different styluses and different pieces of vinyl. One of the other things I didn't like about this Rega as well is that seemingly on the front it had the ground wire when all of the RCA points were on the back, so I've changed that and put the ground on the back in between the power and that first resistor. There used to be an LED there, and you never saw the LED because it was pointing at the back, not at the front. So I've changed that and I've put the LED back to the front. And this here, underneath here, is all of the USB circuitry, and it's a USB chip, and that's a little crystal there. So basically what happens is this flows in, goes through the preamp and goes straight back out. A beautiful design, but then it runs through these, through this 10K pot here, and then onto the USB section, out the USB. So one of the other design flaws of the Rega was that it never adjusted the level out with this pot here. There's a pot on the front that says level. There it is there, level, but it was never level for the RCA outs. It was only ever level for the USB, which was very annoying. And after all, this USB is only 16-bit 44.1K, so I decided I really don't need this. I'd rather record at a much higher resolution on the audio outs into my Apollo sound card. So who needed this USB section? Not me. So I decided to make this a volume adjustment for my analog, which is how I always thought it worked and how it should work. So now we go to R13. R13 and R14 there are the two that adjust the volume for this circuit. So what I've done is I've taken one of them, it's run through here to this little point here, then it's run out of that into here, which runs through this, and it comes back out, back to here, and then back to the second point and out. What this is a temporary switch, like this. I decided to add that so that I could always check to see what the original circuit had as a level. I can use my ears and turn this up, and it actually gets a lot louder than it originally was designed for on this output, but you start to get into a little bit of distortion as well. So every so often, if I want to hear what it originally was biased to sound like. If I push that in temporarily, I'll go, oh, that's how loud it used to be, and I can adjust my level there to get a really perfect indication of what the level was, the way Rega designed, and then I can take it up past it or below it. So if I'm doing a really important transfer and I don't want any distortion whatsoever, and I don't even want to trust my ears, I just want to trust the circuitry, I can check that and I can set it to how it originally was on the level, check the level, yes, that's the exact same level, whether the button's in or out. Then I know that that is matched to that, and that is matched to the original circuit, and I won't hear any difference in level or distortion. And I had to pull out that resistor there and that little resistor there, and they were 820 ohms, so I added them back in here, the 820 ohm little mini resistors there. So when I push that in, it still puts 820 ohms across it. When I let go, then I have control over the output with my level. So it takes it down lower than 820 ohms. So that's it. They're the basic mods to my Rega A2D. So now I've got a nice brightness control. I've got a volume control for my analog out. I've got my LED on the front so I can see what the hell's going on. And I've got a button to trigger to let me know how my level is compared with the original circuit. So here's the finished unit with the LED on the front, the level control for the real RCAs on the back, and my sample original and new level on the front, and where the earth was is now a knob for bias for top end. And around the back we have the plugs and the ground where the LED used to be, in that hole there. But I've just had a good play with it, and I've come to the realization that this sort of original bias position setting could be pretty easily made with just a marking on this level indicator here. So I've got a real pencil there mark already, which you can probably see, which shows the level that it originally was, and then I can go up and down and just do it visually, and I really don't need this button. And it finally dawned on me that the one thing this Rega is missing is a power button, a power switch. It's just on all the time, and I noticed that because the LED was glowing all night and it disturbs me a little bit. So we're going to put a power switch in its place. Before I do that, I thought I'd just show you a couple of extra little tweaks that I've made to this mod. So we have these two surface mount resistors here, R22 and R23, but and they run through to this 10k pot here that has 4.7k resistors across the 2 points that it connects to, which is the bottom two. To split this, essentially its resistance down so that it's got more of an adjustment that is natural, unless having it all the way between 9 and 10, it sort of spreads the adjustment of the bias across more evenly between 0 and 10. But I notice when you go all the way to 10, essentially it's shorting out these points here, and this circuit doesn't really like it. You start to hear a little bit of DC level coming through. It sort of pops, and then you hear a bit of fizzing, and you can hear a very low end rumble. So this circuit's really not designed to have these points shorted. So this is a 10 ohm resistor, and this is a 10 ohm resistor that I've just put in so that this pot never really gets all the way to shorting. It's 10 ohms off, hitting a short, and that seems to have fixed the problem, so that there's always, even if you crank it all the way to the right, there's at least 10 ohms across both of those points, and then that circuit's happy. It's happy with a 10 ohm load. So I'm going to go ahead and remove all this, and we're going to have a much simpler solution now, probably less wires and potentially less hum. And we're going to put a power switch here, which I'm going to link into this power plug here. You'll also notice that for the 10k resistor, pot here, I've removed the two surface mount resistors there because they do interfere with the working of this, and they're not necessary either. They ended up running across to there, then they go to there, then they go through this capacitor here, and then they end up shunting to ground through there. But all it does is just interfere with your level. What actually happened was that the level died, then went up, then died again. It was like setting multiple low points on that pot. So remove those two, and those two connect to the two left side, and then these 2 points here, this one and this one, connect to the middle two points on this pot, and then this one and this one here connect to the far left points on the pot. And this one here, where I put a little dot, is the child of this one here. They're on the same link. So the outers are on the same link, and then the black and black dot and black dots are on the same link. So essentially, instead of chopping, and we still need to cut this, I've cut these tracks here and here, and here, but just before them, where I've glued it. But you probably didn't need to solder to these. You could actually solder to these two here, and use that pot that way. However, it would probably mean that the pot would work back to front, and it would be quieter as you turned it up instead of getting louder as you turned it up. It would save you a couple of cuts, each to your own. Okay, let's go ahead and put this power switch in. Power switch is a pretty easy one. You just have to cut this. This is the positive pin, and the positive pin runs to this resistor here. So you chop through the middle here, just very gently scratching away. And I've scratched away a little bit of the green protection on both of those sides of the track. So now all I have to do is short across those, and power comes on. So we're going to run those 2 points there and there to our little switch. This is our switch here. And that'll fit perfectly in our spot on the front where there used to be a USB slot. So that's look nice and neat. Let's see how it goes. So here we have now the mod of the volume tester, I guess you'd call it, removed, and the power switch installed. So run 2 wires from here, and I've sort of threaded them through and kept them on this side of the board because this is where all the audio stuff happens, and this is the power supply, and you've got some regulators here, and so I'm keeping the power on that side to keep the buzzing and keep the noise away, and then it runs through to this switch here, which is just switching the positive. Thought I'd mention also that I also have installed a couple of resistors on this line which goes to this, the level control. I noticed when you turn the level up it goes into serious distortion because again when it goes all the way to full on you're shorting out those two resistors, and I was a little bit afraid that I might heat up one of these op-amp chips and blow them, plus it sounds pretty nasty. So I put 50 ohm resistors, it's a 50 ohm and that's a 50 ohm, just across this signal path, so you can never turn it up to fully shorted. There's always 50 ohms across, and in that way it sounds a lot less nasty if you accidentally turn the volume up on full. It still distorts when you've got a really strong vinyl groove and a really strong loud stylus, but with 50 ohms across there, if you have a really quiet record and a really quiet stylus, you'll be able to crank it up to full and maybe just tip into distortion. So you've still plenty of gain there to take it right up to full level. It just removes any chance of actually blowing things up. So let's put it all back together now and see how it works and sounds. So here we go. Turn it on. Okay.